In this lesson, you will compare your answers to mine, and if you've got something wrong, then you will correct it on your own homework document. Right, so basically, what you needed to do for this lesson is you needed to basically convert the word equations into chemical equations, right? So I'm just going to insert my function for chemical equations, and then we can begin. So the first one there is iron plus oxygen, which gives me iron oxide, right? So for iron oxide, it is a compound formula which you have to know by heart, all right? And so we know that iron is Fe plus oxygen on its own is O2 because it's diatomic, and then it will be Fe2. That is the chemical formula for iron oxide. So we need to see if this is a balanced chemical equation, right? It's going to take us a little bit of time to basically balance this equation, but that's all right. I'm just moving it in the middle. So the first thing we do is we label the nutrients, right? We label the elements, and we have the same number of elements on both sides. We should have the same number. Right, so the one element that is misbalanced is iron, and as well as oxygen, right? So let's start with iron because it's always easier to start with the element that's not oxygen, right? So iron is 1 over here, and we need to bring it to 2. So 1 times what will give me 2? 1 times 2. And all I need to do is add a 2 in front of iron here, right? So that changes the entire equation now. So this is what I'm left with. And now the next thing I need to balance is oxygen, right? So oxygen on this side is 2. Oxygen in the products is 3. I need to bring 2 and 3 to a common number. The common number between 2 and 3 is 6, right? If I count in 2s and I count in 3s, then the first number that they both will land on is 6. So the next question I ask myself is what times 2 will give me 6 and what times 3 will give me 6, right? Thereafter I go in and just add it. So over here I have oxygen in my reactants, and I know 3 times 2 gives me 6. In my products, I know that 2 times 3 gives me 6, but I cannot put a subscript. I have to put a coefficient, which is the number before the compound, right? And now I tally everything to see if everything is balanced. Everything should be balanced. All right, so we're nearly there. We only have to balance iron now. In order to balance iron, we need to bring the 2 here by the reactants to the number 4. Okay, as we can see in this here. So here it's 4, and we need to bring it to the number. We need to bring the 2 over here to a 4. So how we do that is simple. All we need to do is say 2 times what gives me 4? 2 times 2. Okay, and instead of putting a 2 here, all I need to put is a 4, and that is my balance equation. Just write it properly. There we go. Moving on. So in this example, you had to also convert the word equation into a chemical equation, right? And you know, when you're reading the word equations, it shouldn't be difficult to convert them, and I'll show you why. First of all, nitrogen monoxide. Monooxide means there's only one oxygen, right? So we know that when we are naming nonmetals, when we have two nonmetals together, we name the first nonmetal, which is in the name, which is nitrogen. And usually the nonmetal, oxygen or chlorine, etc., will have a prefix. A prefix is a word that comes before another word. So here we have monooxide, which tells us how many oxygens are there in this compound. Plus oxygen, and oxygen on its own is O2, which gives me nitrogen dioxide, NO. And why is it NO2? Because di tells me that there are two oxygen atoms. Let's see if this chemical equation is balanced. It doesn't look balanced, so I'm going to write it out here. And okay, so we have one nitrogen in the reactants, we have three oxygens, and we have 1 and 2, right? So the one thing we need to balance here is clearly oxygen, right? We need to bring the oxygens in the products and the reactants to a common number of 6. Okay, and how do we do that? We say 2 times 3 is 6, and 3 times 2 is 6. Okay, so let's work on this side where we only have we have one compound. It's not too complicated, right? So what we do is we just add the 3, right? And let's tally it up and see what we get, right? So now we have 3 nitrogens, and we have 3 times 2, which is 6 oxygens. And that will tell us what we need to change on this side now. So we need to change nitrogen. So it's better that if I go right here and change it. So if I put a 3 before NO, let's see what we get now. So now we get 3 nitrogens, and 3 plus 2 is 5, right? Which is not going to give us the same as the same as the products, right? So I need to look for, and this is a special case, and I usually won't give you this kind of chemical equation, but I need to look for a number that is common between 2 and 3, but the next common number, right? So the next common number is the number 12. Okay, whenever this happens where I see that, okay, I'm not getting to the right number, here I have 5 and here I have 6, I need to move on to the next LCD, right? So let's take out this entire table, contents of this table, right? Okay, so let's try this again, right? I need to bring everything to a 12. I need to bring 3 and 2 to a 12, right? So how do I do that? I say 3 times 4 is 12, right? And 2 times 6 is 12 here. So then here, what times 2 gives me 12? We established that it was 6, right? And now I have 12 here, I have 6 ends here. On this side, it's going to be a little bit trickier because I need to think, okay, because remember I have a 2 over here as well. So I need 6 nitrogens. So if I put 6 here, then it will be 6 oxygen and 6 nitrogen. So I have 6 nitrogen, which is correct. Now I just need to get my 6 oxygen. So I need to say 6 plus what, right, times 2 will give me 12. So I'm literally just going to count. So I just have to say, if I put a 3 before O2 here, it gives me 6, right? 3 times 2, it gives me 6. So 6 plus 6 will give me 12. And here we have a balanced chemical reaction. So the rules from this is, if you see that you're not getting to, it's just not balancing, okay, when you're trying to bring it to the closest common multiple, right, between 2 and 3, which was 6, and that's just not working. So you don't struggle with that. You just move on to the next LCD, which is 12 in this regard, right? And that's going to immediately get you the result you intend. All right, moving on. We have hydrogen sulfate plus potassium. Gives me potassium sulfate plus hydrogen. Okay, so how do we write hydrogen sulfate? Remember that there are two ways to say hydrogen sulfate. The first one is sulfuric acid. The second type is battery acid, right? So we have H2SO4. Sulfates are always SO4 plus potassium, which is K, which gives me potassium KSO4 plus hydrogen, and hydrogen, which stands alone, will always be diatomic. Okay, now let's kind of spread out what elements we have. We have H, we have S, we have O, and we have K, right? Same thing on the side. We have H, we have S, O, and K. Okay, let's tally it up. So on this side we have 2 H's, we have 1 S, and 4 O's, and 1 K. On the side we have 2 H's, 1 S, 4 O's, and 1 K. Oh, well, lucky us, this one's balanced. Moving on. So in this example, we have magnesium plus sulfuric acid, which is another name for hydrogen sulfate, as we done in the previous example, which can also be called battery acid. All right, so if I start naming this, it's going to be magnesium, it's just Mg, plus sulfuric acid. Sulfuric acid is hydrogen sulfate, H2SO4, right? Please learn this off by heart. And then magnesium sulfate is Mg SO4, right, plus hydrogen, which is H2. Okay, I don't need to balance anything here. Everything is balanced out. There's 1 Mg, 1 Mg, 2H, 2H, 1S, 1S, O4, O4. Moving on. So here we have sodium oxide plus sodium, which gives me oxygen. Right, so sodium oxide, sodium is a metal, Na, and oxygen, which gives me sodium on its own, plus oxygen. Oxygen is a diatomic molecule, so it will receive O2. Right, let's balance this equation because it doesn't look balanced. Right, so on the reactant side, we have 1 Na, 1 O. On products, we have 1 AA and 2 oxygen. We need to bring oxygen in the reactants to a 2, right? And how do we do that? Say 1 times 2. Okay, and the only possible way we can do this is if we add a 2 before an NaO, right? Remember, we cannot add any numbers next to the elements. Now let's tally it up. So now we have 2 NAs, 2 oxygens, 1 Na on the side, and 2 O's. So the only next thing we need to do is we need to bring 1 to a 2. So 1 times 2 gives me 2. And I just add my 2 before Na. And here I have my balanced chemical equation. It's always nice to write down the numbers in the end. Okay, the next one we're doing is the basic, very famous equation of how water is created. So we have hydrogen, H2, which tells me that hydrogen is a gas, oxygen, which is O2, and also tells me that oxygen is a gas, and it leaves me with hydrogen oxide, and hydrogen oxide is basically H2O. Right, so that's exactly what I'm going to be writing. All right, let's tally it up and see if this is a balanced chemical equation. So we have HO on the side and HO on the side as well. Here we have 2 H's, 2 O's, 2 H's, 1 O. The only thing that's unbalanced is O, and I need to bring it to O to a 2, right? The only way I can do this is by putting a 2 before H2O. Now let's see what we get. So when we put the 2 before H2O, we get 2 O's now, 4 hydrogens, and let's just leave our previous numbers here as is. Now we need to change this side, right? So the only thing we need to change is hydrogen. We need to bring hydrogen to a 4 as in the product. So 2 times 2 is 4, right? And where do we put the 2? We put it before H2. So this becomes 4, this becomes 2, this becomes 4, and this becomes 2. And now we are a balanced chemical equation. All right, so the last one we're going to be doing is potassium bromide plus chlorine, which gives me potassium chloride plus bromine, right? So potassium is K, bromine is Br. Remember that if you do not have this in a proper form, like bromine is B, right? A capital B and small r, right? If you have it in any other way, then it is incorrect. Plus chlorine, and chlorine is a gas. When it is alone, on its own, it's a gas, and it's also a diatomic molecule. Potassium chloride plus, but chlorine, whenever it's bonded to another like a metal or non-metal, it changes its property. It's no more gas, so it's no more diatomic, right? And Br is bromine is also a diatomic molecule, so it has a 2. Okay, so on this side I have 1K, 1Br, and 2Cl, 1K, 2Br, and 1Cl here, right? So this is obviously unbalanced, and I need to balance Br on this side. I need to bring it to a 2, right? And how do I do that? I say 1 times 2. So when I do this, the only way I can change the Br to a 2 on the side is by putting a coefficient. But now when I put the coefficient, I change the case. So I now have 2 potassiums, 2 Brs, 2 chlorine, and on the side I have 1 potassium, 2 bromine, and 1 chlorine. So I need to change. On this side, I also need to change chlorine and I need to change potassium. And I need to bring them both to a 2. And I just do that by putting a 2 before. And now I get 2 of everything. Okay, and that is the end of this lesson. I hope it made sense. Please remember to correct your work on your own homework activity. And yeah, if you have any questions, feel free to ask me.